presentation. Actually, I know this is right after the lunch, so I know and understand it's a little bit challenging, and I will try my best actually to keep it engaging and informative. And I'm Erdi Akin, and I am working in the SOCAR Türkiye in the Star Refinery and the Petkim Petrochemical Complex. I am the integrity manager for the process units. And today I would like to take a moment to talk about digital transformation with GE Vernova APM tailored solution for mechanical integrity. So let me begin what the title means really. So tailored solutions. Here I wanna mean is every transformation is unique. So even though we may use the same software, but still we have different expectations, different dynamics, and different goals. That's why every transformation should be unique as well. So let me continue with the SOCAR Türkiye's introduction quickly. And SOCAR Türkiye has lots of companies, including different energy sectors such as natural gas, petrochemical complex, and refineries as well. Today, I will just focus on the Petkim Petrochemical Complex and the Star Refinery, where we use actively GE APM actually. So let me continue with the first Petkim site. And Petkim has production capacity with the 3.6 million tons. And the Petkim is producing nearly 60 petrochemical products. And let me continue for the Star Refinery. Star Refinery has a production capacity with 12 million tons per year. And these both companies are large scale and highly integrated. That's why we have to use GE APM effectively to manage all of the mechanical integrity solutions. Let me continue with my background actually. So I have a metallurgical and materials engineering background, and I have a master's degree in the engineering management. I have 13 years experience with the mechanical integrity field and such as inspection, corrosion, and the RBI implementation. And I hold several certifications with the APIs and NACE, and that makes me understand this implementation very well. So let me continue with our mechanical integrity applications. Today, mostly I will focus on what type of challenge we are facing with, and how we are solving this challenging. So there are 4 basic modules in the mechanical integrity APM tools. So one of the most important modules, RBI, and IOV monitoring is related to the RBI modules. It's actually related to each other. So policy designer also the supportive modules to the other modules. And we have inspection management modules, and also we have thickness monitoring modules as a basic module. So today I will go over this outline, and risk-based inspection I will mention a little bit, and how we are using the RBI implementation in the SOCAR Türkiye. And after that, I will mention our challenging issues for the IOV monitoring, what type of solution we are doing, and I will continue with the policy designer and inspection management implementation. I will mention a little bit our integrity KPIs as well, and how we are tracking to these KPIs, and inspection management application with the report designer. There can be several benefits by using the report designer in the Visual Studio. So thickness monitoring implementation and asset management online corrosion monitoring, and I will continue advanced entity application with drones. I will finish my presentation with the digital twins, and after my presentation, Miss Melissa will continue her part. Let me continue with the first part, RBI, risk-based inspection. This is the generic RBI application, and this graph explains how you are doing RBI with the step-by-step. Let me continue step by step. First, plan the assessment. Usually, lots of the companies doing ACA analysis to define the scopes, and ACA, asset criticality analysis. But in SOCAR Türkiye, we are taking nearly most of the static equipments to the RBI scope. So this is because of the little bit government regulation. So after defining the scopes, we are defining resource and time required. Resource means here what type of analysis you are expecting. So it can be semi-quantitative RBI 580, it can be quantitative RBI 581, or qualitative. If you are adding customized degradation mechanisms, you can also create a different type of evaluations as well. So after collecting all of the data, you can also upload all of the data to the system, and you can also check if any missing or not. And after that, we are drawing, or we have some corrosion team under our integrity management, and corrosion team is drawing to the PFDs and PNIDs to define the corrosion loops based on the temperature, pressure, flow rate, and whatever it is affecting to the degradation mechanisms, they are defining to the corrosion loops. And after defining to these corrosion loops, you will have the RBI components. And after defining to these RBI components, you will calculate the probability of failure and consequence of failure depending on your data for each degradation mechanisms. And the biggest score for each degradation mechanism will govern your risk. When we multiply the probability of failure and consequence of failure, you will have a risk score. And after you take this risk score, based on your degradation mechanisms and your criticality score, you will create the RBI recommendations. And once you have this RBI recommendations, you can manage your inspection management. You can upload all of these recommendations to the inspection task as well. And you can plan and you can create your inspection task plans, ITPs. And whenever you perform new inspection, you have to do reassessment as well to get the new reassessment scores as well. Let me continue with the risk-based inspection corrosion loop example for the aromatic plants. As you see here, this is just an example, concrete example for the corrosion loops. And if you observe this carefully, one asset can be divided multiple components. Let's see here, just a minute. Let's see here, this column divided two components. And for example, for this distillation column, we have three components based on the degradation mechanisms. Because of the temperature, because of the expected credible degradation mechanisms, we have to do that. And normally in the atmospheric columns, we are expecting more aggressive corrosions at the top of the column. Of course, it depends on lots of variables, temperatures, and the metallurgy as well. But you have to do that. And middle and bottom side of this column, you should expect high temperature corrosions. But the overhead side of the column, you will have low temperature salt corrosion and hydrochloric acid corrosion as well. So depending on your chloride content and other effective parameters. And once you multiply the probability of failure and consequence of failure for each component degradation mechanisms, you will have the inspection priority here. So, and once you take this priority, you will create your recommendations and your inspection plans. Let me continue with the integrity operating windows. That is the most important one for the other mitigation techniques except for the inspection. So here, first we can define what IOV means. IOV is the limits, basically, IOV is the limits that could affect the integrity of any assets. So we are tracking this IOV for proactive action. And we have some IOVs based on the degradation mechanisms, and we are setting these limits according to the international standards, API 581 and API 571 degradation mechanism standards. And when we use these standards, we understand what is the critical parameters that affect the integrity of the equipments. So that means the integrity operating windows. This is not the operational parameters that affects the operational yield. This is related to the integrity operating windows. This is related to the integrity only. So let me continue how we are managing the IOV. So in the Meridium, we have policy designer supporting module as well. So whatever you want, you can create any policy to manage what you imagine. So here we created a policy, and this policy runs daily, and we are getting email notification if any OPC tech exceeds their limit. So as you see here, there are lots of details in the emails, realized maximum value, realized minimum value, and realized average value, and defined upper limit, and how many times your OPC techs exceed the limits. You can create this policy based on your requirement as well. It depends on your expectation. So it can be changed actually. This is what we are expecting. So of course we are getting lots of emails, and so here we have a challenge how to understand monthly distributing, how to understand the big picture. So do we need to sum all of the emails from the emails? No, just we will log all of these records, all of the exceeding records by using the policy event in the policy designer, and you can log all of these email notifications to the system, and once you do that, you can have that type of dashboards. So these dashboards these dashboards will give you a big picture, and you can easily analyze all of the months, how many OPC techs exceed their limits, what is the accumulated time, what is the important parameters, and maybe you can eliminate some of them because of the wrong alarms, maybe because of the thermocouple failure, I don't know. And also you can communicate with the process and operation team as well. So actually, in my opinion, it's very important to log all of this policy exceedings. So if you do that, you can log all of them and you can analyze all of them as well. So this is our solution for that type of challenge. So let me continue with the other policy designer examples. As I said before, this is the supporting modules, and you can do anything based on what you imagine. So here, for example, we have as received prep-up test for the PSV relief valve. So it's very important for us, and we are tracking this one as a KPI. So what we need to do here to track PSV prep-up test failure in monthly. So here, as you see, in monthly we have a policy, and we are getting the email notifications per month, and it says number of pass 9, fail late 0, and fail early or other fail tip 0. And it's also very important to track that type of integrity KPIs. And you can also do whatever it is, and based on your requirement, you can create and you can customize what you need to do. And now let's move on to inspection management module. So it's also important to track all of the KPIs for the mechanical integrity. And here I will show some of the important KPIs and how we are managing it, how we are tracking it quickly and easily. And also that make us easier to report, especially for the audits. And here, for example, overdue inspection tracking and temporary repairs and leakage tracking and PSV prep-up test result tracking. For example, here, as you see, KPI for overdue inspection. And first, we created overdue dashboards, and after that, we connected to this dashboard queries with the Meridium KPIs. And by this way, we can easily understand how is distributed monthly, how is reduced monthly and year. So it's very important to understand how it's your workforce changing, and you can also report these ones to your top management for the integrity activities. Let me continue with the overdue inspection. This is the real-time graphs, and whenever you enter any inspections, and if you cover the inspection task, it automatically reduces the overdue graphs. So you can easily analyze, and you can easily access all of the overdue inspections, overdue equipments by using these graphs and dashboards. And by clicking any of the columns, you will have the related units overdue list. Here we have some series based on the equipment types. For example, this overdue equipment, this is the overdue PSV. And also you can also have that type of equipment types with the RBI overdue, legal overdue, and government regulation. And also you can do some extra series as well, flexible hose or anything you want. So temporary repairs and leakage also important for the mechanical integrity KPIs that we want to track. So here, first, I can explain how we defined temporary repairs, because as a default, we don't have any temporary repair management procedure in the Meridium, in the GE APM, but GE APM give you flexibility to do with your expectation. So what we did here, we created different fields in the general finding family. Maybe you know these families already. And we created the different family and we created this different system codes. We added some pick list, temporary repairs, wrapping, and temporary repairs, fitness for service, that type of things to the system. And whenever we enter this temporary repairs to the system, we can take this graph in the real time. So here we can also have the total failures, total number of failures, and the active temporary repairs in the field. Once you click any column, you can have the temporary repairs, number of the temporary repairs in the field. Right, this now. So let me continue with the PSV prep-up test result tracking. Also, already I mentioned about that, but let me see. Let me show this graph as well again. And here we have 3 series: pass, fail late, and fail early. I can say the important failure mechanisms here fail late, because in any PSV, for any PSV, if it's not working on demand, you will have a HSE event. So fail late means our fail late criteria is 10% of the set pressure. So if your PSV sets 100 bar, and if you take out to the workshops, and once you test it in the workshop, if your scores above the 110, it's fail late. We are saying it's a fail late. So here the other failure mechanisms here fail earlier. It's actually related to operating pressure, and also we are also using the 10% deviation criteria, but it's totally about the blow down pressure and operating pressure as well. But it's caused the leakage, not the HSE event. So the important thing to track for us, the fail lates. That's why we are tracking more, and we are doing the RCA whenever any PSV fail late. So let me continue with the inspection management implementation, deferral form process, and integration with GE Vernova APM. So deferral form process ensures systematic tracking and approval of deferred inspection and the maintenance tasks. Actually, we wanna understand the real risk values together with the process department, operation department, and if we are not performing any inspections for any assets, we have to do this risk assessment as well, and we have to record it with the formal form. So that's why, just a minute, that's why we are tracking to this deferral form, and we are logging all of this deferral form with the risk assessments and approvals. So we are doing it with the third-party software, but we will integrate this software with the GE Vernova APM. So whenever any overdue happens, it will take to the deferral forms OT platform, and we will manage it with the relevant departments. So let me continue with the other important and saving time features for the Meridium GE APM. Inspection management application with Report Designer, Visual Studio. And you can create each report format by using Visual Studio in the Meridium. So, for example, for our case, we need to create government regulation format reports, because each time when we create any inspection, we are manually typing all of these things. It's a little challenging for the engineers. So what we did here, we created this report format in the Visual Studio, and of course you are creating some queries, and you are correlate all of these queries and all of these report formats, and it's automatically printed with the inspection management inspection form here. For example, if you print any report, you can have this report format as well. So in any audit, we can easily print all of these reports, and it saves lots of time before the turnaround. Also, we can print all of these ones. It's really actually saving time for us. So also we are using these report designers for, just a minute, for our automated ITP system. And before the turnaround, we need to print all of the inspection test plans. So you have to take all of the RBI analysis, inspection past history, and let me check here, equipment characteristics, and RBI tasks, government regulation tasks, and RBI risk, probability of failure and consequence of failure data. All of the degradation mechanisms scores. These are the very important parameters to show you equipment criticality and what you need to do in the turnaround. So according to this ITP, you are planning to your turnaround. But this is not also, let me rephrase that. Actually, you can also add another extra information by using datasets. So you can also add any information that doesn't match meridian families. For example, stock of the, number of stocks for the ERP, eddy current scope. There is no meridian families including that type of information. What you need to do here, you will create simple data sets and you will upload to the system, and whenever you upload to the system, you can open to the Visual Studio and you will correlate all of this information with your data sets, and automatically it will take the related equipment. So here, as you see, just by clicking one button, you will take all of the updated ITP as well here. So it's really saved time for us with the last turnaround, and it's very important. Also, we are adding these reference documents to these ITPs, and automatically you can take all of these things with just one button. Let me continue with the last important modules, the thickness monitoring implementation. We have a CML procedure, and we are managing all of the thickness measurements by using our CML procedure. And we are calculating the number of CMLs by using the table 1. Length factor, fittings factor, and corrosion rate factor based on the RBI analysis. So table 2 represents the distribution of these CMLs. Degradation mechanisms, based on the degradation mechanisms, you can distribute your CMLs, or you can say the TMLs, at the turbulent area, straight pipe, weld, and dead legs. If your expectation is erosion corrosion, usually what you need to do, put your CMLs turbulent areas. So let me continue with another another thickness monitoring implementation things for us. And here there is a graph representing all of the TMLs unit by unit, and here TML number, piping tech number, piping circuit number. Once you click any one, you can easily understand how many TMLs we performed in the related units. So a total of we have 1.2 million TMLs we performed in the SOCAR Türkiye. This is the huge number actually, but we are taking support from the subcontractors as well. Because Petkim has been operated for 40 years, we are taking budget for managing these TMLs as well. So whenever you click any of them, you can understand the scaffold size and access type and insulation requirements. So you can plan easily before the turnaround how many TMLs you need to measure, and how many TMLs you can do on stream inspection, so based on the temperature as well. So all of this information will be uploaded to the system and by the data loaders, and by this way we are managing easily. And after the first baseline implementation, all of these TMLs, also you can use the data logger. Data logger is very useful, especially for the repetitive measurements. So let me continue with the remaining life monitoring and corrosion rate monitoring.
We've got about 2 minutes.
2 minutes, okay. Okay, I will continue fastly. Okay, and remaining life, we have remaining life graph, but for a challenge, let me quickly explain what type of challenge we are facing with the remaining life. Here, our expectation is to have 2 remaining life calculation. One of them, corrosion allowance and mil tolerance. The other of them, actually, minimum pressure design thickness and structural thickness, whichever is greater. So why we are expecting that? Because if you just follow corrosion allowance and mil tolerance, it will be more conservative. Sometimes piping specification says to you, especially for the stainless steels, 0 corrosion tolerance. So even in the beginning, you will have the 0 corrosion, 0 remaining life. So that's why I want to follow, as a company, we want to follow these 2 remaining life approach. And first, we are following to the corrosion levels and mil tolerance by using this graph. And after that, how we solve that one. And we uploaded all of this minimum pressure design thickness that we calculated outside the meridium to the system. We changed the one field characteristics, and we uploaded all of the minimum pressure design thickness to the system, and we calculated all of this remaining life scenario by formalization in the query expression. You can also do that in the query expression, and this is a little bit challenging, but still is possible. So we are managing it with the 2 remaining life approach. Let me continue with the other asset management, online corrosion monitoring things, but also Melisa Hanım can explain that type of things briefly, and I can actually hand over the stage to the Melisa Hanım. Thank you so much.
First of all, I would like to express how delighted I am to be here. Thank you for the kind invitation. Let me allow to introduce myself briefly. I am Melisa Ersoy. I'm working as a digital transformation specialist at SOCAR Türkiye. I've been working with SOCAR Türkiye for the past 4 years. And also I would like to give some brief information about SOCAR Turkey's digital transformation, especially in the asset management and health, safety, environment HSC domain. We focuses on innovative solutions to improve our processes, improve our process safeties, and drive sustainability. Our digital transformation efforts span across various technologies from industrial robotics, process mining, AI, VR technologies, video analytics, image processing, condition monitoring, predictive analytics, RTLS, I mean real-time location system, and also additive manufacturing and mobility. Today I will go deep dive some digital transformation knowledges about our company, and also I would like to talk about connected worker technologies. Let me deep dive into main focus areas. Through our private LTE network investments, we have built a reliable and secure communication infrastructure. It enables us uninterrupted connectivity. It supports real-time data collection, and also it provides us the fully control all over the network, ensuring data security, low latency, and optimized performance. Also, by using this network, we implemented connected worker technologies like worker and also asset tracking and also the monitoring. This robust connectivity also play a crucial role in enhancing predictive maintenance capabilities. It allows us to gather, analyze data from critical equipments like our steam traps, PCV valves, pumps, compressors, and etc. In our work on online corrosion monitoring, we aim to provide continuous corrosion tracking using the private LTE network. Let me continue by condition monitoring and predictive analytics parts. We can predict potential failures and optimize maintenance schedules. This predictive maintenance capability actually ensures that we reduce downtime and extend lifespan of our time. Our most critical systems also supported by the private LTE network that we mentioned before. I can continue with the robotics and drones parts. The integration of robotics technologies and also drones in our operations is a key part of our digital transformation strategy. These technologies are used in our field to inspect hard-to-reach areas like sealing, reactors, and pipelines. Especially, it reduces the need for human intervention and increasing operational efficiency in the dangerous areas. Also, drones are also used for the data collection, inspection. It enables us to gather accurate, real-time information from challenging environments. Furthermore, robots are used for maintenance, cleaning, and also delivery tasks. It significantly improves our speed and efficiency of operations, and it reduces our downtime. So let me continue with the last part. We are focusing on the image processing video analytics technologies. We utilize advanced video analytics to monitor worker behavior and also identify the safety violations such as non-compliance with personal safety equipment. You can see the video. It's taken in our field. Additionally, we ensure facility by security by detecting unauthorized access, unusual activities in real time. So these technologies also help monitor critical processes and operations. It ensures adherence to safety protocols and enhance overall operational security. Last one, we are focusing on the AR, VR technologies, integrated digital experience projects. We provide immersive training environments where employees can practice complex and hazardous tasks safely. These VR solutions skills without exposure to danger, improve troubleshooting, and it's also repair capabilities and enhance workers' understanding of complex processes. As a conclusion, SOCAR Turkey's digital transformation efforts focuses on leveraging technology to improve safety and efficiency and skill development. Thank you for listening.